Now 4 statements are given and we need to identify which of them is false. So we need to identify the false statement out of these 4 statements. Let's verify the validity of each of them. Let's consider the first one. Let's treat a new function g of x as f of x plus x minus 1. Now for this function g of x, can you tell me what is g of 0? Yes, it would be f of 0 minus 1. Now what is f of 0 minus 1? Can you tell me whether it is positive or negative? As the function is defined to be between 0 and 1, 1 is the greatest value of f of x, right? Therefore, and it is continuous, therefore f of 0 minus f of 1 would be less than or equal to 0, right? Since f of 0 value should be less than or equal to 1. Now similarly, what is g of 1 from this definition? Yes, it would be f of 1 plus 1 minus 1, that is simply f of 1. But as f is defined from 0, 1 to 0, 1, this f of 1 value should be greater than or equal to 0 because f of 1 should be on 0 to 1, right? This is also given by the definition of the function. Now what did we observe here? G of 0 is negative and g of 1 is positive. What do you mean by that? Yes, the important observation goes is g of 0 and g of 1 have opposite signs. So by intermediate value theorem, if there is a change of sign when there is a change of sign from g of 0 to g of 1, what can we say? There exists at least one c in the interval 0 to 1 such that g of c becomes 0 because the g of function value is changing the sign from negative to positive. That means it is crossing x-axis at somewhere. Wherever the function g of x is crossing the x-axis, there the functional value becomes 0. But what do we mean by g of c is 0? Yes, f of c plus c minus 1 should become 0. Or shall we also say f of c is 1 minus c. So there exists at least one c belongs to 0 to 1 such that f of c value will be equal to 1 minus c. And the statement A which is given is true. Therefore, statement A is clearly making sense and it's a true statement. So we observe that A follows to be a true statement, but we need to identify the false. So A is not a suitable option for us. Let's move ahead to the function B. Here in B, what is given? F of 0 and f of 1 are equal and f is defined from 0, 1 to r. Then there exists a c belongs to 0 to 1 such that f of c equal to f of c plus half. Let's verify the truth value of this. So now we are trying to attempt the B's validation. Let's consider a new function now. Let's consider a function g of x as f of x plus half minus f of x. Now by definition, as f is continuous, even g of x is also a continuous function. Therefore g of x is observed to be a continuous function. Now can you tell me what is g of 0? Yes, it would be f of half minus f of 0. But by definition it is given that f of 0 value is same as f of 1. So when we replace f of 0 with f of 1, f of half minus f of 1 is the value of g of 0. Now let's also calculate g of half. What is g of half now? F of half plus half, that is 1 minus f of half. So this is minus of f of half minus f of 1. What did we observe here? This is the negative of this expression. Then g of 0 and g of half, one of them is f of half minus f of 1, then the other one is negative of that value. So can we say g of 0 and g of half have opposite signs? Now g of 0 and g of half has opposite signs. So what can we conclude on this? That says g of x equal to 0 will have at least one root in 0 to half, because between 0 and half g is changing its sign. That means it is crossing x-axis. Where it crosses x-axis, the functional value becomes 0. Now what do we mean by g of x becomes 0? Yes, that means f of x plus half will be equal to f of x for some x belongs to 0 to half. But if 0 to half, which is also a subset of 0 to 1, if there is one root between 0 and half, then obviously that will be at least one root between 0 and 1. Now if you look at the statement B, that's what the statement says. F from 0 to 1 is continuous, then there exists a C belongs to 0 to 1 such that f of C will be equal to f of C plus half. Therefore, what did we observe here? The statement B given is also true, right? So this statement's truth value is, this is also true. That means this is not the required choice as we wanted false. So let us see what is waiting for us at C. Now for the choice C, which says f is from 0 to 1 to 0 to 1 is continuous, then at least one C belongs to 0 to 1 such that f of C will be equal to C. So from the given condition, as f is defined from 0 to 1 to 0 to 1, right? Then the value of f of 0 will be clearly between 0 and 1, and the value of f of 1 will also be between 0 and 1. And also importantly, given that f of x is continuous. Now what do we mean by f of x is continuous and it is defined from 0 to 1 to 0 to 1? Shall we conclude from here that f of x attains all values between f of 0 and f of 1? Now when we represent this as a graphical notation, this is 0, then at 1 the functional value at f of 0 and the functional value at f of 1. However the graph be, it takes all values between f of 0 and f of 1, and if you draw the line which is y equal to x, this is our graph of y equal to f of x. Now what do we observe here? Yes, the important observation is the graph of y equal to f of x in the interval 0 to 1 will definitely cut the line y equal to x at least one point. Now wherever the graph of y equal to f of x cut the line y equal to x, can we say the equation f of x equal to x will have at least one solution in 0 to 1. Then there will be a C belongs to 0 to 1 which satisfies this equation, that is f of C equal to C. Now if you look at the C option here, yes, correctly that only there exists a C belongs to 0 to 1 such that f of C value will be equal to C. That means even the C option is also having truth value as true. So therefore the choice C is also true. But if you look at the question, we need to identify a false statement. But we observed that A is true, B is true and C is true. So which is a false statement? Correct. None of these is a false statement, right?